Good morning students. So welcome to this session of Bridge course. So in the previous two sessions we have discussed about distance and displacement and some MCQs related to whatever concepts we have discussed. So just like that, today let us move on to few more concepts in physics without which we cannot continue the chapter of physics. Okay? So today I am starting with another concept which appears to be similar just like distance and displacement, but actually there is a greater difference between the two. So that concept which appears to be same but has slight difference between the two is speed and velocity. So today we will be discussing about speed and velocity. Now, first let me state the definitions of both, and then later with many examples we will understand the topic clearly. Now to begin with, speed is defined as rate of change of distance traveled by a moving body. So speed is defined as rate of change of distance of a moving body traveled by a moving body of a body. So the definitions will vary like this, but the meaning conveyed is the same. So this is the definition of speed. Next let me move on to velocity. So velocity is defined as rate of change of displacement. So displacement of a moving body. Of a moving body. So just looking into both the definitions, you are clear that distance is associated with speed concept. Displacement is associated with velocity concept. Okay. So before going into depth of the concept, one more thing I need to clarify here. Seeing at the definition, you should be able to write down the formula. So formula I have seen many students bahating every time. Need not bahat. If you understand the concept, you can make a definition. Using that definition, you can frame a formula. Using that formula, you can write down the unit. Using that unit, you can write down the dimension also. So you need not bahat everything in physics. These are some of the key things what you have to remember. Now, seeing this definition, how to write down the formula? So formula for speed can be written as, since the definition says rate of. So in my previous video also I had told you rate of. Wherever this sentence comes, this word comes, it is 100% confirmed that in the denominator I have to add time factor. Rate is different, ratio is different. I have not written ratio, I have written rate of. So whenever in any definition, not only this concept, this topic, wherever in physics you are getting a sentence starting with rate of, it is clearly understood that in the denominator we have to write the time factor. So let me put a fractional bar. So in the denominator I have to write a time. In the numerator, rate of change of distance. So in the numerator I have to write down what? Distance. So from the definition only I have written the formula. What is the formula for speed? Speed is equal to distance traveled divided by time taken. Simply instead of telling distance by time, so to make it a more defined manner, we will write it as distance traveled divided by time taken. Clear? Okay. Now distance by time is speed. Now recall your velocity definition. many of them get confused between distance displacement and speed and velocity because the units remain the same. Distance unit is also meter, displacement unit is also meter. I am talking only about SI units. So when it comes to speed unit, meter per second. When it comes to displacement unit also, when it comes to velocity unit also, it is meter per second. Okay. So now we wrote definition, we wrote formula, and from formula we were able to write down the unit also. Now let us clearly understand the concept by taking certain examples. Okay. So I hope you can follow the words written on the blackboard. So today I have written a little bigger. So now let us illustrate some of the examples and see what is the difference between the both. So in my first example, a car is traveling at 50 kilometers per hour in northeast. So this is a sentence given in some textbook or in any numerical problem. How to identify whether the given data is speed or velocity? Again, moving back to definitions what we have written and formulas what we have written. For speed, we wrote it as distance by time. Distance by time. And for velocity, I wrote it as displacement by time. Displacement by time. Now go back to previous session. Displacement and distance. What is one of the basic difference? In distance, we don't consider direction. Hence, distance is a scalar quantity. When distance is a scalar quantity, speed is also a scalar quantity. Scalar quantity is a physical quantity having only magnitude. There we won't be concentrating on the direction. Clear? So since distance is concentrated only with respect to its magnitude, speed is also concentrated only with respect to its magnitude. Hence speed is a scalar quantity. Now let me go back to velocity. In velocity, we have displacement by time. Displacement is always related with the direction. For this, we have written yesterday few MCQs also. If directions are given 100%, it is not scalar quantity, it is vector quantity. Similarly, here since displacement is represented both in magnitude as well as in direction, it's a vector quantity. Velocity is also a vector quantity. So I have given you the difference between speed and velocity in this table. So difference between speed and velocity can be asked for 2 marks. Actually whatever now I am teaching in the bridge course, this is first chapter in first PUC. So based on that only I have picked some of the topics. So speed equals distance by time, velocity equals displacement by time. Can you define looking at the formula? You can write out the formula based on the definition. Looking at the formula also you should be able to write out the definition now. See, time factor is there in the denominator. So how will you tag a sentence? Rate of change of distance traveled by a moving body. Rate of change of displacement traveled by a moving body or of a body. So scalar quantity is speed, vector quantity is velocity. Now let us go back to our example. A car is traveling at 50 kilometers per hour in northeast. So 50 kilometers per hour is representing magnitude. It is representing the value. Okay. Northeast is representing the direction. So here in the given example, we have both magnitude also as well as direction also. Both magnitude So in the given example, 5 meter per second cannot be velocity, but it is 100% speed value. Clear? Now let me take my third example. A car is traveling at a rate of 60 km per hour due east. So this is my third example. Okay. A car is traveling at a rate of 60 km per hour due east. So here 60 km per hour represents magnitude. Something indicating the direction? Yeah, there is. So east is representing the direction. Again in the given illustration, I have both magnitude as well as something indicating the direction. Since direction and magnitude both are indicated, it is again a vector quantity. When I say it is a vector quantity, again it has to be velocity. So out of the three examples what I have given, so looking at whether only magnitude is represented or both magnitude and direction is represented, you can identify whether the given data is speed or velocity. If both magnitude and direction are indicated, then it is confirmed that it is velocity. Only magnitude is represented, then it confirms that it represents speed. So this is one of the basic difference between speed and velocity. Sometimes in competitive, they don't give any sentence representing the direction. So they don't mention due is traveling in northwest direction. No directions will be represented, but instead of that, they put an arrow mark like this. So arrow mark also represents direction. So usually for vector quantity, whichever I say it is a vector quantity, we represent an arrowhead. So here V represents velocity, and just now we learned that velocity is a vector quantity. To represent that velocity is a vector quantity, I need not write in words. Instead of that, if I just place an arrowhead, we call it as arrowhead. So on the head you are representing the arrow mark. Now this represents a what? Vector quantity. Now so far whatever we have learned in our journey, clear? Displacement is a vector quantity. Usually displacement is represented by a letter S. So in the place of S, if I write the arrow mark, it is clear that it's a vector quantity. Out of these two, again velocity represents vector quantity. So on the top, if I write an arrowhead, then it is understood velocity is a vector quantity. So just like this, in the examples, if I place an arrow mark like this, arrowhead either upward or downward, then it also indicates velocity quantity. So it's a vector quantity. So it cannot come under the category of speed, it has to come under the category of velocity. So these are some of the examples to make you clear between speed and velocity. Many times we consider both same. Instead of writing displacement, write distance. Instead of writing velocity, write it as speed. No, we should not do that. So we have to understand the sentence properly. We have to go thorough with that, and then we have to manage writing them. So this is one of the basic concepts. Okay. So let me give you another examples also. Another one important example. So in some illustration, the difference can be in that part also. So now imagine there is a cyclist. A boy is riding on a cycle. A cyclist starts his journey from point A at a speed of 5 km per hour and comes back to the same point A. So there is a cyclist who starts his journey from point A magnitude. When it represented only magnitude, we confirmed that the given data comes under the category of speed. When both magnitude and direction are given, we confirm that the given data comes under the category of velocity, as it is a vector quantity. Sometimes in order to represent the direction, they can use arrow marks also, either upward arrow marks or downward arrow marks. So in my fourth example, I have told you that, okay, if the displacement turns to 0, if the starting journey point and ending journey point remains the same, then displacement will be 0. When displacement is 0, obviously velocity will be also 0. So using these 4 illustrations, I hope you have got an idea the difference between speed and velocity. Now, let me move on to the next concept. So in the next concept, I will be covering acceleration. So now let us start with acceleration. Now, what is acceleration? Imagine you are sitting on the back side of a car and the driver starts the car. And while starting the car, there is a jerk what you feel. If you are leaning towards the seat, okay, you experience a jerk like this when the car is being started, okay? And imagine you are sitting inside a car and the car is traveling with certain speed and suddenly the car turns. It takes a turn. There is a curved road and the car takes a turn. When it takes a turn, suddenly you are pushed towards the turn where it takes. Clear? Now here all acceleration is being experienced. How to make the concept now clear about acceleration? So to begin with, let me define acceleration. Acceleration is defined as rate of change of velocity. So look into the definitions clearly. Rate of change of distance, speed. Rate of change of displacement, velocity. Rate of change of velocity represents what? Acceleration. So now let us write down the formula then. Okay? Now since acceleration is usually represented by a small letter A, some of them you will write this as capital letter A, but board concentrates on small letter A for acceleration. So again when I told you, wherever rate of comes, it is clear that in the denominator there has to be a time factor. So in the denominator I have written time. Rate of change of velocity. So what should come in the numerator? So in the numerator there should be velocity. So now acceleration is equal to velocity by time. Now can we write the unit looking into the formula? Can you try now? Okay, try this. So when you are trying, think about velocity formula. What did we write? Velocity formula, meter per second divided by, again what is time unit? Time unit is also second. Now this second is also in denominator. This second is also in denominator. Can I write this as meter per second square? So meter per second is velocity unit. Meter per second square represents acceleration. So just like how I told you in the previous case, retain numerator as it is. Bring this denominator term to numerator. When you are bringing this denominator term from denominator to numerator, it will become inverse. So it is meter second minus 2. If you are not comfortable writing like this, no worries. If you write like this also, you will be getting complete marks. Meter per second square. You need not worry. So some of you will write it, instead of making mistake while rising, it is better to stop it here. Clear? So meter per second square or meter second minus 2 is the SI unit of acceleration. Now let us understand the concept again by taking certain examples, because now just by writing the definition and writing the formula, the concept is not clear. I am giving you illustration only in order to attend competitive. In competitive, identifying the data is very important. So with this is board part. And in PU board exam part. So this part is not sufficient for solving the competitive. Now let us illustrate certain examples and see where all acceleration comes into picture. So in the first example, I write two sentences. In the first sentence, a car is traveling in a straight line. A car is traveling in a straight line with constant speed of 60 km per hour. In the same example, I write another sentence. An aeroplane is traveling along a straight line. An aeroplane is traveling along a straight line with a constant speed of 1000 km per hour. Now let us read both the sentences once again. A car is traveling along a straight line with a constant speed of 60 km per hour. An aeroplane is traveling along a straight line with a constant speed of 1000 km per hour. Now in the given two example, where do you think acceleration is involved? I have written two examples. Go through the two examples cleanly now. And just to think, where actually acceleration is involved? If your answer is an acceleration is involved in first case, wrong. If your answer is acceleration is involved in second case, it is also wrong. Because in both the cases acceleration is not at all involved. How come? How come acceleration is not involved? Man, speed is changing, man. Here it is 60 km per hour and here it is 1000 km per hour. How are you saying that acceleration is not involved? change in direction. If there is change in direction, there is change in velocity. If there is change in velocity, it is confirmed that you have changed the direction. Now recall what the example I gave you in the starting of the acceleration part. I told you when you are sitting inside a car. Okay? So the car is being pushed. There is change in the direction. When it starts the car, the driver starts the car. And similarly, I told you another illustration. You are sitting inside a car and traveling along a straight line, and suddenly the car takes a turn. So in this turning area, you are experiencing the acceleration because there is change in the direction. Whenever there is change in the direction, it is displacement. Whenever it is displacement, it is velocity. So change in velocity creates acceleration. Change in direction creates acceleration. Change in direction is nothing but displacement. Now link everything. They are all linked together. So in this first example, whatever I have written, so though the speed value is changing from 60 to 1000 km per hour, since both of them are traveling along a straight line, acceleration is not involved in any of the cases. In both the cases, acceleration is not at all involved. I hope this illustration has given you an idea about what is acceleration. Now let me take another example. In the another example, a moving body starts its journey, say from point A at 30 km per hour, takes a turn towards right. So body is turning here. Again at 30 km per hour and continues its journey with 30 km per hour. So this is another illustration wherein the body starts its journey from point A with 30 km per hour, takes a turn towards right at 30 km per hour and continues its journey with 30 km per hour. Now in this example, is acceleration involved or not? If you have understood the previous case, you should answer this. Here again, acceleration is involved. Don't say this not involved. Just by saying this term 30 km per hour, 30 km per hour, 30 km per hour, don't think acceleration is not involved, ma'am. There is change in direction. Ma'am, then what does this constant represent? This constant is representing speed value. 30 km per hour, 30 km per hour, 30 km per hour. What is remaining there? It is representing speed value. Since there is change in direction, look into this block. What I have written? Whenever there is change in direction, 100% there is change in velocity. Whenever there is change in velocity, it represents acceleration. So in the second example, though for upper view, when you see the values remain same, don't think acceleration is not involved, but 100% here acceleration is involved because there is change in the direction. Okay? So these two illustrations you have to thoroughly understand in order to understand acceleration. Now let me come to the third example. A body starts from A, that is from rest. A body at rest starts its journey from A. So there is a ball. So from A and moving it like this. Okay. So at the point A, it was at rest. Okay. Now it went on increasing its velocity. So 5, 10, 15, 20, 25, 30. And by the time it reached B, it attained a velocity of 30 meters per second. So question won't be so much in detail. Actually, they'll just give a sentence. A body starts velocity of 30 meter per second at point B. So a sentence will be given to you like this. So starting from rest, it started its journey. So starting from rest means initially the value of velocity was 0 meter per second. Can you see change in the velocity value? 5 meter per second, 10 meter per second, 15, 20, 25, 30. So when it reached a point B, its velocity is 30 meter per second. Is there change in velocity now? Yes, there is change in velocity. Is acceleration involved in this process? Yes, acceleration is involved in this process. Though there is no change in direction, but there is change in velocity. So whenever there is change in velocity, obviously acceleration is involved. Whenever there is change in direction also, acceleration is involved. So now here, two velocities I need to concentrate. One is initial velocity and the other one is final velocity. So in physics, initial velocity is represented by a letter U. So U equals 0 meter per second. So when it reached at point B, what was its final velocity? B, 30 meter per second. So in 5 seconds, sorry, I forgot to tell you, in the example they have also mentioned the time factor as 5 seconds, 10 seconds. So like this it won't be there, 5, 10, 15, they won't give you this plot. They'll just tell you like this, a body starts from rest at point A and after 5 seconds at point B, it gains a velocity of 30 meter per second. So time value is also given 5 seconds. Now using this data, how to calculate acceleration? So in this case, acceleration equals final velocity minus initial velocity with respect to time. So in such a case, you have to calculate acceleration using the formula v minus u by t, where v represents final velocity, u represents initial velocity, t represents time factor. Don't think unit will change. No, unit won't change because velocity minus velocity will give you velocity only. Velocity unit is meter per second, time unit is second. So second into second, second square, meter per second square, acceleration will remain as it is. So nowhere acceleration unit is going to change as you change the formula. Remember this point also. This is not only for acceleration, for any other physical quantity. Just by changing the formula, unit won't change. If you simplify that formula, again you will be getting the basic unit only. So this is another version. So according to definition, you can write down the formula. I have showed you already. A is equal to v by t, velocity by time taken. According to this, you have a unit meter per second square. So this is another version of acceleration. When two velocities are given, initial velocity and final velocity. So the formula to calculate is v minus u by t. Here u represents initial velocity, v represents final velocity divided by time. So according to given data, a is equal to v is 30 minus u is 0 divided by time 5 seconds I told. 30 minus 0 is 30. 5 6 are 30. So answer is 6. Wrong answer. If you just write 6, it is not at all a physical quantity. To have physical quantity along with magnitude, I have to compulsorily write the SI unit. Remember first session. So if I write 6, you will be losing 1 mark. So 6 meter per second square is the final answer. Okay. So this is another illustration where you have to understand, oh, there can be two velocities. As the velocity go on changing, definitely acceleration is involved. As direction changes, acceleration is involved. If speed changes, acceleration is not involved. So remember that car and aeroplane example. So there the speed was changing. If speed changes, acceleration is never involved. Because many of them will tell you the speed changes, acceleration is there, which is a wrong concept. So acceleration is involved only if there is change in direction. Obviously there is change in direction, there is change in velocity. In this example, though there is no change in direction, there is change in velocity. Because it had 0, while coming to point B, 30, it has attained, it is understood that, oh, from 0 it is moving on to 30 means definitely there is change in velocity, there is increase in velocity. Okay, so there are still many cases. So since this is bridge to make you to understand acceleration. So today we discussed about difference between speed, velocity, acceleration. Okay, so make a notes out of it. Don't just listen and say, ma'am, it's good, it's nice, but when you come to the regular classes, I want to see your notes there. So with all these examples, because I might forget the examples, you should not forget the examples. You have to be thorough with these ideas when you enter first PUC. Okay. So next very important, our hero in physics is force. Without force, we have nothing to do in physics. So these all terms got into existence only when motion came. So in the first class I told you, the moment motion was born, physics got its birth. So similarly, there is no displacement, no distance, speed, velocity, acceleration, force without motion. This all happens only when motion happens. Now immediately, when I ask students to define force, the first two words that come in their mind is push or pull of a body. So this is one of the basic definition. I do agree, but in PU this definition will change. So let us look into that definition later. So now I will go with your ideas only. So to begin with, first definition, you write this push or pull. So this push or pull can make a body to move. Okay. Does it mean to say that force means only moving, only pushing? No. Imagine your friend is throwing a ball at a high speed from other side, and to stop it, from your both hands you are applying force and holding it. Now you are stopping the motion. The earlier person was providing the motion using the force. Using the same force, now you are stopping the motion of the body. So force can create motion, produce, and write whatever words you like. Produce motion, it can stop motion. Okay? So don't be under an idea that force means always it enables the body to move. No, a moving body can be stopped by applying the same force also. So force can create motion in a body. Force can stop motion in a body. Sometimes in the house, when playing with kids, we roll a ball. And even if they don't catch, even if they don't apply force and hold that, after some time the ball rolls and comes to rest. Now is force involved in this example? Yes, force is involved. Which force is involved? Frictional force is involved. Because when you roll the ball is coming in contact with the floor. Now, if the ball is going in this direction, then friction acts in the opposite direction. So don't be under the idea force is only one type. There are so many forces: contact forces, non-contact forces, deforming forces, restoring forces. This journey is huge actually. In 10 minutes or 5 minutes I cannot complete the topic of force. So I have just taken a basic few examples to make you understand what is force. But in whole first PUC you will be learning about all these kind of force. Gravitational force, this you all know. Okay. So an apple falling from down. Okay, sorry, falling from up. It has to fall towards the ground. So immediately you say, oh ma'am, Newton saw apple derive the expression for force using Newton's second law of motion. The measurement of force, how you can measure a force using a mathematical formula, was clearly explained by Newton. You have a chapter called Newton's laws of motion. So Newton did much research on motion, movement and all. So using his law, so we write an expression. So I'll just borrow that expression now. So F equals m into A, where m represents mass of a body, A represents acceleration of a body, and F represents force. Now whether this force is a scalar or a vector quantity, look into this formula. I am writing an arrowhead on the top of acceleration. Arrowhead on the top of acceleration represents that acceleration is a vector quantity. Because acceleration is a vector quantity, force is also a vector quantity. Mass is not a vector quantity, it is a scalar quantity. Mass, 5 kg sugar, 10 kg onion. Does it represent direction? No, it represents only magnitude. So mass represents only magnitude. So it is a scalar quantity. So in this formula, when you write, you should not simply blindly put arrowheads. You should know which all are scalar quantity and which all are vector quantity. Displacement, vector quantity. Velocity, vector quantity. Acceleration, vector quantity. Force, vector quantity. Mass, scalar quantity. Time, scalar quantity. So like this, you should know the difference between scalar quantity and vector quantity. If you are depicting them both with respect to direction and magnitude, then they are vector, otherwise they are scalar. Now using this formula, let me write the unit for force. So force unit is mass is kg, acceleration is meter per second square. So force unit is kg meter per second square. This entire unit Newton changed by his name, hence SI unit of force, we write it as Newton. Newton. Here another thing you need to concentrate is, when I am writing the symbol, I am using capital letter. When I am writing the complete name of the unit, I am beginning it with small letter. These are certain rules we have to follow while writing the unit. This will be also done to you in detail in the first chapter. But this is a small hint I am giving you. Whenever you are writing the symbol of the unit, every time I can't go on writing Newton by its complete words. If I write capital N, it is understood that I am writing it as Newton. I am writing the unit. When I am writing the complete name of the unit, I am starting with small letter N. Okay? So this is about force. So force I have not went into the depth. So it's like a big ocean. So throughout your journey of first PC, you will be learning about force. I have just mentioned the basic criteria what you have learned in your high school. Okay, so push or pull, it can create motion, it can stop motion, it can undergo deformation and all. So in the next class, I will be telling you, so what all parameters we have learned so far, how to write dimensional formula for that. Definition, formula, SI unit, dimension. Today I have told you using definition how to write the formula, using formula how to write the unit. So in our next session we will be seeing using the formulas how to write down the dimensions. So tomorrow I will be taking dimension, and along with that we will be discussing certain MCQ questions also. Okay?